At the first part of our experiment, I needed to calculate the capacitance of every capacitor separately with the capacitance meter that you can see, capacitance multimeter that you can see over here. So this is a 100 microfarad of a capacitor which has a 100 microfarad of capacitance, and I calculated it. As you can see, it measures something so close to it, and we did it for the other capacitors as well, which has these different capacitors such as 100 capacitance, microfarads, 33 microfarads as far as I remember, and then let me check the last one. And 330 microfarads of capacitors, and we calculated all of them by this capacitors, and after putting them in series and in parallel, that you can see later after this part, we also calculated the capacitance. So at this part, I charged the 100 microfarad capacitor first with 20 voltages, and then I connected it series with these two other capacitors which has 200 microfarad of capacitance and 33 microfarad of capacitance. And then after doing this, I calculated I measured the voltages one by one. Let me just show you. So this is the first one. So as you can see here, this is the voltages of first one, and I calculated it for all of them. And before doing that one, I created the circuit one more time, and with this capacitance multimeter, I calculated the equivalent capacitance for the circuit. Okay, so I connected all the capacitors in parallel and I charged the capacitor with 100 microfarads first with the power supply when it's giving 20 volts. And then after charging this one, the capacitor till the time that it is completely charged to 20 volts, I put it away from the power supply and I connected it with other capacitors, and I tried to create a circuit which actually the charge in this capacitor is somehow passing to the other capacitors, and I'm trying to find the equivalent capacitance. Well, I found it before, so I'm trying to find the voltage after everything is done. And now you can see that it is 0.281 volts. So this will be the when I first charged this one, it was like 20 volts, but after connecting them in parallel, the circuit has almost like 0.3 volts of voltage.
In conclusion parts, I calculated the equivalent capacitance and the charge on the capacitors for both circuits that are made of capacitors in parallel and series. In order to make error zero, we can repeat experiments multiple times, and we can use more precise multimeters and so on. We used the principle C equals Q over V, where C is the capacitance of a capacitor, Q is the charge, and V is the voltage. Using that formula, we calculated the capacitance, equivalent capacitance in different circuits. That's my Physics 102 project for spring semester.